Oh, happy
That's
belated
good.
birthday.
Okay, so today is the last lecture of chapter 6, so tomorrow's review day, and then test will be on Friday. Pretty straightforward today. We're continuing with vectors. Again, a lot of these formulas will be on your formula sheet, so you might want to have that out so you can look at them. A dot product is this right here. That is not a multiplication symbol. That literally is a dot. So please recognize that. I mean, but you will know it's a dot product when it says u dotted with v. You're going to multiply two vectors together. Well, how do you multiply two vectors together? You multiply the first pieces of the vector, you multiply the second pieces of the vector, and then you add them together. Your answer is what's called a scalar. It turns out to be one number. When you do a dot product, you get one number. You do not get another vector. And then the last thing you need to know about doing dot products, this is another way to figure out if two things are perpendicular or not. Okay? Orthogonal vectors, which is another fancy word for perpendicular, is when you do the dot product and it turns out to be 0. So, if we go to compare slopes, right? When you compare slopes, how would you know when M1 and M2 are perpendicular?
Minus 0.
When you compare slopes.
Opposite.
What?
Reciprocal and negative.
Negative reciprocals, right? In other words, when you take M1 times M2, you get -1. That's back when you guys first learned to start working with linear stuff, the linear functions. M1 times M2 is -1. Do not confuse that today with the orthogonal has to be 0. And I think there is sometimes, in 2 days from now, you guys are going to mix those up. So know what it is. If you're working with the slope, use the negative reciprocals idea. If you want to work with the vectors themselves, use the dot product equal to 0. So we're going to just quickly do a couple of dot products. If I take the dot product of this first one, I would take 3 times 7, and I would add to that 5 times -5. So you're just multiplying the x's, you multiply the y's, and then you add them together. So I end up with 21 minus 25, and it looks like we're getting -4. Are these two vectors orthogonal?
No.
No, it didn't add up to 0. Not orthogonal. So what I'm going to ask you to do is quickly do B and C on your own, and then I'll pause it, and then we'll come back and look at the answers. So do B and C.
I'm just gonna say.
I really worked hard, you guys.
So if you look at B, you would have taken the x's, which would be the 2 times 3, the y's, which would be the 3 times -2, and you get 6, and a -6, and when you add them, you get 0. So that is an example of orthogonal vectors. Down here, -5, -6, when you multiply all that stuff out, I get -25 and -36 for -61, so that again is not orthogonal. Pretty easy, right?
Yep.
Does anyone find it terribly difficult?
No.
No. And I'm saying that with a little bit of sarcasm because what happens is on the exam there are about 4 or 5 questions on the test. You'll see today we use dot products and a couple other formulas, and people mess up the dot product. They mess up the dot product. The most common mistake is you guys write it down as like -25 comma -36. You write it down as a vector. But when you multiply, when you do a dot product with these vectors, your answer is a scalar. It's just a single number. So before Friday's test, make sure you just go back and review what is a dot product. Okay? So we're gonna do a couple of things here. I'll do the first one with you again, and then maybe you guys can try these. So when you look at it, a little bit of order of operations. I need to do the dot product first. I have to do my dot product first. So U dotted with V, I'm going to do here. That would be 3 times 2, the X times the X from U and V. Then I take the Y's, which are 5 and negative 1, so I'll add to it a 5 and negative 1. So I'm getting 6 minus 5. So I'm getting a dot product of 1. This expression is telling us take your dot product times vector W. Well, what happens when you multiply by 1? It's nothing. So there's your vector, and that's your answer. So now we've been doing all these dot products. We've been doing all these dot products, and we've been getting scalars, and now we're dealing with some dot products and vectors, and the answer is vector. So I know maybe it gets a little confusing for you guys, but you just got to watch your answers. So I'm going to pause again. You're going to do B, C, and D as fast as you can. B. You have to do the multiplication of 2 first. That's the only thing that would make sense. Then do the dot product of those 2 vectors. So remember, our answer will be this number, which is just a single number or scalar, not a vector. When you look at C and D, what it's describing is, doesn't matter if you take the vector and call that my first vector and this one the second, or if you reverse it. No, it doesn't, because in both cases you're multiplying your x's together, and it doesn't matter what order you multiply in. Multiply your y's, doesn't matter what order you multiply them in, and then you're adding those numbers together. So you'll get the same dot product even if you do v times v dotted with u or u dotted with v.